now, how can AI help us revolutionize maritime transport? If we could have to the stage Michael Triantafyllou, who's an ocean science and engineering professor at MIT, and also the director at MIT's Sea Grant program, and who will help us solve these questions in a conversation with Vassilis Papakonstantinou, who's head of tech at Blue Dome Capital, and excuse me, Mr. Triantafyllou will be on Zoom, so we won't have him on stage.
Thank you.
Thank you.
Good morning. Thank you for joining. Unfortunately, Michael had a minor health issue, and although he's very close, he couldn't get here. I met Michael through his work back in 1993 or 1994 when he, the MIT Technology Review actually reviewed Robotuna, one of the first water robots that they applied biomimetic principles. So, Michael, welcome. I hope you feel better. I want to start the discussion by asking you, the work you've done with Robotuna got a lot of people talking about the potential of biomimetic principles. What are the most important takeaways from studying, these, fish locomotion, the way that they understand the environment, and how these principles have influenced robotics and autonomous marine vehicles over the years?
Good morning, everybody. I'm glad I'm not with you. I'm fine, just a small virus. Thank you, Vassilis, for this introduction. The work in the Robotuna at the time was the first that addressed the issue of how we can improve performance in the water, whether it's a surface or an underwater vehicle, by using unsteady excitation, unsteady fins, moving parts, which at the time was very unorthodox, very against the grain, because propellers were operating at steady speed. Everything was supposed to be moving at a fixed rate. Everything was passive. And yet, the environment in which ships and vehicles operate is very unsteady. There are waves, currents. In fact, huge storms are more of a norm. So the operation in a calm environment is more of an abstraction than a reality. So the world of fish brought in these new perspectives, that the flow is unsteady, that the fish need to sense their flow at all times, so they have sensors distributed all over their bodies. Their bodies are flexible, and therefore brought a completely new paradigm. So it was the introduction of also soft robotics as a new enabling technology, which came later. And it was, I think, a direct inspiration from these results, as well as the sensing studies we did later on all the various sensors that fish had, robots. The Robotuna was followed by Pike, which was a very maneuverable fish. Then Snake inspired AUVs, that autonomous underwater vehicles that were used in the offshore industry to inspect lines, enter difficult locations, which offered completely different new perspectives. And the new MANTA program, which is inspired by the manta ray structure and activation of DARPA. But more than that, it brought to mind what biomimetics can bring into the picture. And so other studies followed. For example, the soft robotics that I mentioned, and then the self-healing methodologies. For example, clams and oysters have ways of detecting stress in their shells and they use that stress to heal any cracks, any wounds they have, and many animals do that. So with the proliferation of very inexpensive sensors, for example, when we did the MEMS study for sensors, we were able to construct sensors with a cost of a few cents each. That allows us to distribute sensors in locations which were unthinkable before. And that could create hulls of ships which can sense locations where they need scrubbing, where there are problems, and therefore become self-aware the same way that fish are.
So, if you look at the...
I would say that but gravitated to solutions. Yes, go ahead, Vassilis.
So, the picture you're painting gets me to think that the work that we have done in the water outperforms the way that we have replicated what happens in nature above water, meaning that we were inspired by the birds to build airplanes, but we don't have flapping airplanes. What you describe underwater, the applications of biomimetics have diffused much more, but we still don't see many underwater robots making headlines. I remember your work that you used to discover the wreck of Antikythera, but how do you see this space of underwater robotics growing?
Well, you brought the good analogy with the birds and the airplanes, because in that case, one of the major functions of airplanes is to produce lift and at high speeds. So in that case, we don't replicate the birds because the steady wings can produce a lot more lift. So it's a different situation. We don't have that underwater. Underwater, especially for autonomous vehicles, agility is the major factor. If you want to do repairs underwater, you have to go in a cluttered environment, be able to sense around you with a variety of sensors where you're going to have all sorts of acoustical flow sensors. A combination of them, you have to do merging of all these sensor signals and be able to replicate the environment, and then an extreme agility, ability to maneuver in a tight environment and without infinite power. You have to have a limited power. So the ideal solution for that would be a sea lion, for example. So what prevents us, a robotic sea lion? So what prevents us from having it today is that we don't have the soft materials to build such a hull, but we're getting there. Also, until recently, we didn't have the computational capability, but now with neural networks, we can do that. So AI is coming in a big way, and new manufacturing methods are coming. It's coming through the way. So I fully expect that we're going to see very soon autonomous by inspired underwater robots in a grand scale in the ocean.
So I'm glad you brought that up, because the other area is the surface vehicles, and we see that AI is reshaping navigation and autonomy in many modes of transportation. So the question that I know a lot of people in the shipping industry have: what happens with autonomous vehicles? You know, what are the opportunities? What are the hurdles that's stopping us from getting autonomous vehicles, autonomous vessels crossing the seas or in the ports?
Yeah, this is one of the major opportunities and challenges we have today. There's no question that AI is revolutionizing the ship navigation and autonomy. The hurdles we have is primarily regulatory barriers. The sensor limitations we have right now, the fact that the environment is so unpredictable and unsteady, we have cybersecurity risks, and above all, human acceptance. I think the first step is to think of autonomous ships as not necessarily unmanned. So a ship can be autonomous but still have a skeleton crew. I think that is a more realistic vision that is coming up. But right now, a lot of people are working in a multimodal sensor fusion where radar, AI, vision, hydroacoustics, LiDAR will provide us this real-time 360-degree awareness combined with sensors in the hull, which will provide a major enabling capability for that. We have to resolve cybersecurity risks. So that is another area of hard work. The same thing about maritime data. We need maritime data from many ships because we need to combine data and have a global picture of all the fleets that are available so we can synchronize motion and safety, and the same way air traffic controllers work for airplanes. So we have to use blockchain secured data. We have to have a lot of backup controls because AI may fail. We need ways through AI cybersecurity to detect anomalies in case there is hacking or malicious intervention. Human in the loop. So there are many challenges, but I think the technology is converging very rapidly. And the way I see something from within the next few years, I would say 3 to 4 years, that we will have semi-autonomous ships. We have seen a few in Norway, for example, primarily ferry for short duration routes. And I think by 2035, we may have fully autonomous coastal and freight ships. So they are already planning them in Norway again. But I think it's something very, very, very much doable. And this is very applicable to Greece as well. And then in the long run, I have no question that with AI-driven, there will be shipping autonomy. I can bring other issues like collision avoidance that we're doing now. Using the biomimetic principles I mentioned earlier, we can do much enhanced maneuvering. I've done studies where I have shown that location of fins on underwater vehicles, which can be applied to ships, can enhance maneuvering by several times from what we have today. So it's an exciting opportunity.
So essentially the picture is that it is coming, it will not be human less, it will be human augmented in a sense, much like Waymo. Right now there is a remote driver that controls the car in case that something happens. And the coastal part will be the first one. I've seen some examples of tethered ships that they could actually. I saw yesterday a company incorporated based in Texas, I think, that they are dropping some small surface vehicles from planes, and but it was for defense purposes. One of the problems we had so far, and I think still remains, is the electrification, which is a prerequisite for getting to autonomy. You cannot maintain autonomy without electrical propulsion. Do you think that is a problem?
I'm sorry, Vassili, we had a very short interruption. It's my a connection which was unstable. If you can repeat the question.
Yes. I was saying that electrification is a prerequisite to having autonomy, because you cannot have autonomy with I think with the traditional mechanical propulsion systems. So do you think that this is part of the delaying factors, or you feel that this is not keeping things behind?
Well, electrification is well on its way. In fact, at Sea Grant, where I'm the director, we have a project since 2002 on on designing electric ships. The Navy is interested in ships for many reasons. So we're well on our way to electrification. The cruise ships are in a major way in that direction. So yes, that will be a major enabling technology. It's coming up. We have the technology almost there. So this is not a major delay right now. It's right at our door. Accepting it on a grand scale will be gradual, obviously. We cannot change ships overnight. But the trend as we go along, we have to keep this strongly in mind. Especially, as I said, coastal navigation will be the first to be to apply these new methodologies, including the electrification.
The need for electrification is also part of the pressure for carbon neutral shipping, and as part of this discussion, nuclear propulsion of commercial ships came back into the table. And I read recently ABS approved the first Korean container ship. What do you think about the technology, the regulation, the safety challenges of having commercial ships running on nuclear fission or fusion, hopefully soon?
These prospects are very real. Until recently I was a skeptic myself. But now it turns out that, as you mentioned, ABS has provided the first such approval. And Korea is actually at the forefront in this domain. The Koreans have approved likely uses of a particular reactor, the small modular reactor, which has certain advantages. So the nuclear technology has improved in the direction we want. So it's not going to apply to all ships, of course, and has major hurdles ahead. But instead of being an impossible technology, all of a sudden now it looks like a likely technology for at least a subset of the ships. Now, what are the major hurdles here? Well, the first is, of course, the reactors. We need new reactor design and miniaturization. So we have already 3 modern designs which offer passive safety features, low maintenance operation, the features that are desirable for ships. The fuel should last 10 to 20 years, so they don't need to refuel. And we need low enriched uranium. So there are specific technological issues which are addressable. Regulatory challenges, the IMO has to come on board. It's not objecting, but it's a slow process. There are issues of nuclear liability and security. So we may have specific nuclear-only shipping lanes and special harbors, which requires a lot of investment. We have geopolitical non-proliferation concerns. Who is going to have those ships? Third world countries, for example, they don't have a supervisory board for nuclear protection, may not be allowed to have such ships. There are safety and public perception challenges. People may be reluctant to see them in their harbor. We have all these hurdles. So what I see is that there is a trend, and in fact we have a new consortium at MIT in the ocean science and engineering area, starting now, and one of the major issues, together with the nuclear engineering department at MIT, we're doing a study on nuclear-powered ships. But it looks very likely that the early adoption will be at the state level. States will adopt it. For example, China, the US perhaps, Korea, Russia. And it will not be private sector driven because of all these hurdles. The technology is almost ready. That was my major surprise. By seeing all the facts now, it's moving rapidly. So this will be an area that we are going to see a lot. But as I said, I don't see it coming from the private sector.
Yes, I assume the risk of all these moving parts, especially part of the regulation, make it less desirable for the private sector to invest, and it requires huge amounts of money. As we're wrapping up, what do you think as of a game-changing technology in the field of maritime? We discussed about several ones, but which one do you think or advise the younger people in the room to look for and get involved in?
Well, the whole marine area is changing rapidly. I will mention one which is my favorite because I think Greece may have a good chance of getting into, which is the entertainment industry. There are these so-called e-foils, which are little vehicles with one rider on them. They have a propeller, they have a battery. Some of them are oscillated by the person on top, and these move at 30 miles per hour. The Greek seas are calm, and there is a potential, an unlimited potential of producing thousands of them, which are now produced in Australia, in the US, in Croatia, in France, but not in Greece. And that combines the art of naval architecture with electromechanical devices and the like. But going further than that, I think what will really excite me is that within the next decade, we're going to have AI-driven fleets of vehicles mapping the deepest part of the ocean. We're going to have self-healing ships with distributed sensors all over their hull. Right now, your iPhone has about 50 sensors on them because they cost 10 cents each. So there will be abundance, superabundance there is an explosion in the number of sensors we'll have available. And AI is the only way to fuse all this data and manipulate them, and we have these capabilities. So we'll be able to control pollution on ships, scrap them, and in a self-healing manner. All this requires people to be conversant with AI, conversant with the new manufacturing technologies. You can have on-board manufacturing on ships and the like. So we're in a new era, and there is a lot of opportunity. And I think AI is especially useful. It's not like in the old days where you were taking some knowledge and you taught it and then applied. These are tools which will allow you to innovate. So AI is a good tool, so you can open your startup, you can combine things, and we have to look in that direction. MIT students, when I was there as a student, they wouldn't think of opening their own company. Right now, 25% of the graduating class goes into startups and growing. So that's, I think, what the future for the ocean is too.
Thank you, Michael. Thank you for joining us, and I hope that you get well soon. See you soon.
Thank you for having me.